Hi everyone. Today I'm going to show you how to calculate another way, or basically another way to calculate delta H, and that's called the standard heat of formation. So the standard heat of formation allows you to take the heats of each substance and then add them together and create the delta H of the entire reaction. So in order to do that, there is a table that you need of all the heats of formation of specific substances. So this table that I have here, I have actually put this on Schoology for you. I believe it is in the folder May 4th to May 8th, standard heats of formation. I believe that's what the table is. One little tidbit of information here is that any substance in its natural state is going to have a standard heat of formation of 0. So for example, I know it's a little hard to see here, but bromine, for example, as a liquid has a standard heat of formation of 0 because at 25 degrees Celsius and basically 1 atmosphere pressure, bromine exists as a liquid naturally, so that's why its standard heat of formation is 0. Same thing for carbons. You notice there are two different forms of carbon. So the first one is the diamond, and it has a heat of formation of 1.9. But carbon's naturally existing state is graphite, and so it has a heat of formation of 0. So as you go through and solve the problems, make sure that you look at things like chlorine or fluorine, iron, hydrogen, whatever they are in their natural state, or the elements, by the way, not compounds, but the elements are going to be a standard heat of formation of 0. So no compounds are going to have heats of formation of 0, but elements in their natural state. So we're going to be referencing this table as I go through and solve some of these problems. So I'm going to do a couple with you. So using standard enthalpy of formation values, calculate the enthalpy of combustion of this reaction. So C2H6 plus 3.5O2 produces 2 CO2 gas plus 3 H2O liquid. So it is going to give you some of the less common substances that are not on that table that I gave you. And so in this case, they gave you C2H6. So to calculate delta H using enthalpy of formation values, it's the delta H of the products minus the delta H of the reactants. So delta H of the products minus the delta H of the reactants. So my products are CO2 gas and H2O liquid. So my delta H is going to be 2 times CO2 plus 3 times H2O minus C2H6 plus 3.5 O2. So when you do this, you take into account the moles. So basically the coefficients that are in the front. So 2 times CO2 as a gas. So I go back to my sheet. 2 times CO2 as a gas. CO2 as a gas is negative 393.5. Plus 3 times H2O as a liquid. H2O as a liquid is negative 285.8. Minus, now I'm subtracting my reactants. So C2H6 is negative 84.68 plus 3.5 O2. O2 is 0. So basically plus 3.5 times 0. So now you're just going to solve and do the math. So I'm just going to do each part separately because why not? So 2 times negative 393.5 plus 3 times negative 285.8. So I get negative 1644.4 minus a negative 84.68. So when I do that, I get negative 1559.72. And it looks like that's going to be in kilojoules. Since these are exact values, we generally don't use sig figs here, so I would probably leave my answer as 1559.72. So again, I'm not using sig figs because these are exact values. So that's how you solve for standard heat of formation. I'm going to do another one. So again, delta H is products minus reactants. So I'm going to do 2 times NH3 plus 4 waters minus my reactants, so 2 times NO2 plus 7H2. Okay, so 2 times NH3 as a gas. So NH3 as a gas is negative 46.19. Plus 4 waters. Water as a liquid. Water as a liquid is negative 285.8. Minus my reactants now. So 2 times NO2 as a gas. NO2 as a gas is 33.85. Plus 7 H2s. And H2 is 0. So now I'm just going to solve each side basically. So 2 times negative 46.19 plus 4 times negative 285.8. So I get negative 1,235.58 minus 2 times 33.85, 67.7. So then negative 1,235.58 minus 67.7 is going to get us negative 1,303.28. And that's going to have a unit of kilojoules. So again, when you do this, it is products minus reactants, and you're going to use the chart that I posted for you. If the substance is not on the chart, chances are it's probably in the problem. I'm going to do 2 more. Oh, 1 more, sorry. Using standard enthalpy of formation values, calculate the enthalpy of the reaction. So I have HF for H2S, and I need to find delta H. So again, I'm doing products minus reactants. So my products is going to be 2 SO2 as a gas plus 2 H2O as a gas. Notice that now we're doing water as a gas instead of water as a liquid. Minus 2 times H2S as a gas plus 3 O2. So 2 SO2. So 2 times SO2 as a gas. SO2 as a gas, negative 296.8. Plus 2 times water as a gas. Water as a gas is negative 241.8. Minus our reactants. So 2 times H2S, which is negative 20.17. Plus 3 oxygens, and we know oxygen is 0. Okay, so 2 times negative 296.8 plus 2 times negative 241.8. So I get negative 1,077.2 minus 2 times negative 20.17. So minus a negative 40.34. So my delta H turns out to be negative 1036.86 kilojoules. So that's how you solve for standard heat of formation. One other type of problem that they might give you is they might give you the delta H and they might ask you to solve for one of the substances in the problem. So if that was the case, you would set this part equal to the delta H for the reaction, and then whatever one they are asking you to find, you would set that as your X. And then you would go through and you would just use algebra to solve for the missing substance. So there you go for heat of formation. So now I've shown you how to calculate delta H 3 different ways. So the thermochemical equations, Hess's law, and now using standard heat of formation. And so again, make sure that you're doing products minus reactants and that you are using this chart, and that can be found in Schoology in the May 4th to May 8th folder. Have a great day, guys.